We continue the discussion on area, on integration. And here we are going to discuss about area under graph and area between graphs. So let's start with the definition. If y equals to f of x is non-negative, and integrable over a closed interval AB, then the area so then the area under the curve y equals to f of x over AB is the integral of f from A to B. So this is what I'm saying, that area A is given by the integral from A to B of f of x dx. So this is we can make a sketch of what we mean here. That if this is x-axis, this is the origin, this is y-axis. So f of x is non-negative, then it means that f of x is in this first quadrant. So y equals to f of x. So if this is A, then this is B. So the area under the curve between A and B, this area, so this area is what we're saying that is given by the integral. So here, area equals to integral from A to B of f of x dx. So note that area is a scalar quantity. So if the region is below the x-axis, the integral will have a negative sign, and the area is the absolute value. So let me demonstrate this in an example. So example, find the area of the region between the x-axis and the graph of the function f of x equals to x cubed minus x squared minus 2x in the interval -1 to 2. So the first thing is to sketch the graph between the interval specified. So to sketch this graph, the easiest thing is to get where the graph cuts the x-axis, which is the same thing as getting the zeros of the function. So zeros of f of x obtained by solving this. So we'll have x cubed minus x squared minus 2x equals to 0. Then we can factor x and we'll have x squared minus x minus 2 equals to 0. So one value of x is 0. So which means x equals to 0, or x squared minus x minus 2 equals to 0. Now this is quadratic, so we can check whether we can factorize this. So product is -2, sum is -1, numbers is -2 and 1. So we can have x squared minus x minus 2 as x squared minus 2x plus x minus 2 equals to 0. So common here is x into x minus 2. Common here is 1. X minus 2 equals to 0. So we'll have x plus 1, x minus 2 equals to 0. So therefore, zeros are x equals to 0, x equals to -1, and x equals to 2. So then now we can sketch the graph. So this is the y-axis, this is the x-axis. So note that when x is 0, y or f of x will still be 0. So f of 0 is still 0. F of -1, when you replace -1 for x in the function, you will get 0, and also this is 0. So here we have -1, say 1, 2, 3, 4. So we have 0 here, we have 0 here, we have 0 here. And this is the sketch of this graph. So between the x-axis and the curve, then these are the two areas we need to obtain. So this is the function y equals to x cubed minus x squared minus 2x. So the area, which is the integral from -1 to 2 of f of x dx. Now we split into two parts, -1 to 0 of f of x dx plus 0 to 2 of f of x dx. So I'll have integral from -1 to 0 of x cubed minus x squared minus 2x dx plus 0 to 2 x cubed minus x squared minus 2x dx, which will be x power 4 over 4 minus x cubed over 3 minus x squared. Then you apply limits from -1 to 0 plus x power 4 over 4 minus x power 3 over 3 minus x squared, 0 to 2. So when you put in the limits, this first value will be 5 over 12. When you apply in the limits, this one will be -8 over 3. But since we are interested in finding the area, then this negative sign is the area value, is the absolute value of that answer. So you get the absolute value of this. So the answer will be 5 over 12 plus 8 over 3, which will give you 37 over 12. Then let's define area between two graphs. So if f of x and g of x are continuous with f of x being greater than or equals to g of x throughout the interval AB, then the area of the region between the curves y equals to f of x and y equals to g of x from A to B if the integral of f of x minus g of x from A to B. This is to say area A is integral from A to B of f of x minus g of x dx. So maybe we can sketch this. Actually, this is how this is a scenario. We can have this is as one function, this as the other function. So this will be y equals to f of x. This is y equals to g of x. So this is the y-axis. This is the x-axis, 0. So this is A. This is B. So we are talking of this area. So area is given by this formula, f of x minus g of x is integrated from A to B. Or we can have this sketch. Can have this sketch. So this is y equals to f of x. This is a graph of y equals to g of x. Then this is where we have the b. This is where we have the a. So this region. So the integration from A to B of upper curve minus lower curve. Or we can have such a structure. Y equals to f of x. Y equals to g of x. So this is where we have the A. This is where we have the B. So we are talking of this region. So in all these three cases, case A, case B, and case C, shaded area is given by integral from A to B of f of x minus g of x dx. So let's give an example to illustrate how you need to work with problems of this nature. So find the area of the region bounded above by the curve y equals to 2 e raised to power minus x plus x, below by the curve y equals to e power x over 2 on the left by x equals to 0, and on the right by x equals to 1. So always when you are solving problems on area, you must sketch the region or the graphs given to know which one is the upper curve and which one is the lower curve. So solution. So in this case, the line x equals to 0 to the line x equals to 1. So just a minute, let's share again. So we have the line, this one, this x-axis, and the maximum value of the first curve is 2. So I have 2. So when you sketch this, this is the curve y equals to 2 e power minus x plus x. And then we have this other curve, which is y equals to a half e power x. So here the value here is a half. So this is 0. And our interest is to find this area. So area, we're integrating from 0 to 1. Their top curve is 2 e power minus x plus x minus the lower curve, which is a half e power x, then dx. Then using substitution method, we'll have area is minus 2 e power minus x plus a half x squared minus a half e power x. Then you supply limits from x0, x equals to 1. So when you substitute, you get 3 minus 2 over e minus e over 2, which will give you approximately 0.9051 square units. So the key thing is to first sketch the graph to know which curve is on top. And then once you have known the graph which is on top, then you can easily compute the area by using the formula integral from a to b, then of the function f of x, which is the top curve, minus g of x, which is the lower curve. So we can also integrate with respect to y. So for example, if you have this as your x-axis, this as your y-axis, then you have, say, this is one of the graphs, x equals to g of y. Then we have another one here, say x equals to f of y. And then let this be d, and then let this be c, and we have this shaded part. Or this is case A, or we can have x-axis 0, y-axis. Then we can have this. This is x equals to g of y. Then we can also have this. This is a graph x equals to f of y. Then let this be c, and this point, let this be d, such that we are interested in finding the area of this shaded part. So this case B, or let's say we have this case C, where we have, say, this an arbitrary graph y equals to g of y, x equals to g of y, and we have this other graph x equals to f of y. Let this be D, let this be C. And so the interest is to find this shaded part. So in all these cases, shaded area is the integral from y equals to C to y equals to D of f of y minus g of y. Then variable of integration will be y. Or simply area is integral from y equals to C to y equals to D of right curve minus left curve, then dy. And in the previous case, you can say the area is simply area is integral from x equals to a to x equals to b of top curve minus lower curve, then dx. So that's how we write them. So for example, find the area of the region enclosed find the area of the region enclosed by the curve x equals to y squared and x equals to y plus 2. Sometimes the limits are, like in this case, may not be directly given to you, but then you should be able to get them. So for example here, for the two graphs, x equals to y squared and x equals to y plus 2 implies that y squared should be the same as y plus 2, which tells us that y squared minus y minus 2 equals to 0. So product is minus 2, sum is minus 1, numbers minus 2 and 1. So you have y squared plus y minus 2y minus 2 equals to 0. So y into y plus 1 minus 2 into y plus 1 equals to 0. So which means then y minus 2, y plus 1 equals to 0. So which means that we'll have y equals to 2 or y equals to -1. That's where the two graphs are meeting. So this is how And then we have this. So this will be -1. And then this -2. So here is 4. And here is 2. So they are this part. Actually, the question was to restrict area to this positive pattern. So find the area enclosed by the region enclosed by the curve, this and this, and the positive x-axis. So the positive x-axis is this top part. So this is a curve x equals to y squared, and then this one is x equals to y plus 2. So shaded area will be integral from y equals to 0 to y equals to 2 of the top curve is so you have y, the right curve. So remember, in this case, it's always right curve minus left curve. So then dy. So this will be y from 0 to y equals to 2. Right curve is y plus 2. Left curve is y squared. Then dy. So I'll have 2y plus y squared over 2 minus y cubed over 3. Then from 0 to 2. Then when you supply the lower and upper limit, your answer should simplify to 10 over 3. And if the question didn't restrict for us to find the area between the two curves and the positive x-axis, then it means that we'll be integrating from -1 to positive 2. This is positive. So y will be from -1 to positive 2 if we are to find the whole area between these two curves. But because of the restriction, then we are only moving from 0 to 2 along the y-axis. And then you take the right curve minus the left curve. So another example on area between curves. So find the area of the region enclosed by the parabola y equals to 2 minus x squared, and the line y equals to minus x. So here we have so 2 minus x squared should be the same as minus x because these are the y values. So which is the same thing as saying x squared minus x minus 2 equals to 0. So product is -2, sum is -1, numbers -2 and 1. So we'll have x squared minus 2x plus x minus 2 equals to 0. So x into x minus 2 plus 1 into x minus 2 equals to 0. So x plus 1, x minus 2 equals to 0. So x equals to -1 or x equals to 2. So those are the points where the curves are meeting at x minus 1 and y minus 1. So when x is -1, y will be -1, which is 1. And when x is 2, y will be -2. So then now we can sketch the two graphs to know which one was on top of the other. So this is the y-axis. This is the x-axis, 0. Then this is the line y equals to -x. Then let me draw this one properly. So the parabola equation, if you pick a few values of x and y, you should get that this is how the so this is -2. This is still 2. So the interest is to find this shaded area. So this is a curve y equals to 2 minus x squared. This is y equals to -x. So then here, area, shaded area, is from x equals to -1 to x equals to 2 of the top curve minus lower curve dx, which is integral from -1 to 2. Top curve is given by 2 minus x squared. Lower curve is given by y equals to -x, so minus minus with plus. So dx, so which will be 2x plus x squared over 2 minus x cubed over 3, then x from -1 to x equals to 2. When you do the correct thing and you replace in the x values, you get 9/2 square units. So get as many more examples as you can on area and solve them.